Okay, and we're live. So thank you all for coming. Right now we're still on break because of the quarantine. We finished off with vectors last time, so I'm going to keep going with that. A couple things to point out before we really get started. So I'm going to be working with a bunch of physics problems today. The main equation we need to know is F equals ma. Force is mass times acceleration. We looked at a couple component vectors when we finished with projectile motion last time. Mostly just horizontal motion and vertical motion. So this first example is a little bit easy, but we'll be looking at parts of a force vector that aren't just horizontal or vertical. So more specifically, this weight vector that I'm showing here, which is going straight down. So I've got this boat that's on a ramp, and we've got a force that's needed to pull it up a 15-degree incline. I want to find the combined weight of the boat and the trailer. So that's all of this part that I've got here. Okay, so to find this weight, I'm going to break apart this force of gravity into two parts, or two components. So that's this first component here in blue is my force of the boat on the surface. And then my second component here in purple is the force pushing the boat down the ramp. So I've broken apart this gravitational force vector into a blue vector that is perpendicular to our surface and a purple vector that is parallel to our surface. Any questions so far?
No.
Okay. So the next thing I'm going to do is I'm going to look at our angles. I was told that we had a 15-degree incline, so I've already got this angle here. But if this is 15 degrees and this is 90 degrees, since this is going straight up and down and this is a horizontal line, then what should this angle be?
$75.
75. Okay, so I've got a 75-degree angle up here. And if this is 75 for this angle here, and we know that the blue line is perpendicular to the black line, then what should this angle be here?
115.
15, perfect. So I'm going to flash that really quick. Here's our angles. 75 degrees and 15 degrees. Okay, so using that, we can start to set up a sine or cosine relationship to solve for either the force of the boat on the surface or the force that's pushing the boat down the ramp. So my sine setup will look something like this. The sine of this 15-degree angle right here should be my opposite over hypotenuse. So that would be this purple line here, the force pushing the boat down the ramp, divided by my red line here is my hypotenuse, is the weight. Because this force pushing the boat down the ramp, this one here, is the same as my force vector here in red, should be equal and opposite to my force needed to keep the boat in place. We actually already know what that force vector is. So I can go ahead and write that too. We were given that we need 600 pounds of force to pull the boat and the tramp up the trailer. So right now, we have 600 pounds of force that we would need in order to balance that. Okay, so that means we can solve this equation for weight then. So I'm going to multiply both sides by our weight and then divide by the sine of 15 to get our total weight here. Any questions for the first example?
No.
All right. So a little bit more complicated then for our next one. I'm going to jump down to the same one that you guys can see. So make sure I open this the right one. Cool. Okay, so a little bit more complicated. I've got these two cables that are supporting a load of 5,000 newtons. Both cables are anchored 24 inches above the load, so I know that this one right here is 24. So this line and this line are measuring the same distance. with 1 anchor 10 inches left of center and 1 anchor 20 inches right of center. So I've got my picture here on the left. Okay, so the first thing I can do, if I want to be able to solve for the force of tension in each of the cables, that force of the tension is the force that's needed to keep this object stationary. So that means each cable is going to have a force of tension that is pulling in this direction. So I've got here force 1 and here force 2. Okay, that force of tension would also have a vertical and a horizontal component. Okay, so I've got 2 force vectors that are currently holding this block up, force 1 and force 2. I'm going to use these distances to determine the angles that we need on the load in order to solve for these force vectors. So I could say something like this. I'm going to break this apart into 2 angles, so angle A and angle B. So I could say if this is 24, then the tangent of angle A should equal my opposite over my adjacent, so that's 24 over 10. The tangent of angle B should also be opposite over adjacent, or 24 over 20. So that gives us 2 different angles that we can solve for. So I'm going to jump in and actually save those in the calculator really quick. So if you're using your own calculator, I'm going to swap this over to degrees first, and then we'll do the arctangent of 24 over 10. And I'm going to store that value as A so I can use it later. And we'll do the arctangent of 24 over 20. I'm going to store that value as B for later as well. Okay, so we've got 2 angles, A and B, that we solved for using the distances that we were given. Okay, so with those angles, we can start to set up a system of equations. So because our load is stationary, all of the forces acting on the load horizontally should balance, and all of the forces acting on the load vertically should balance. So vertically, I've got 2 forces that are pulling up. So this is the vertical component of our first vector and the vertical component of our second vector, and I've got 1 component that's pulling down, which is the weight, or 5,000 newtons. So that gives us our first equation here. In order to get how much of this vector is going to be acting vertically, I could use a sine function for my angle. The sine of my angle would be the opposite over hypotenuse. So I could say that the sine of B, for instance, would be equal to my total large line here, my hypotenuse, is V2, and then my opposite side here is what I want. So that would be V2's y component. Therefore, V2's y component is V2 sine B. Okay, so this part right here is the vertical tension of our second point. And this part over here is our vertical tension of our first point. Okay, so with that, I've got 1 system of equation on bottom that is our vertical forces. So gravity or weight. Okay. And a second system that is what's happening horizontally. So horizontally, we've got these 2 parts that are acting in opposition to each other. So that's V1 cosine A and V2 cosine B, or the horizontal parts of V1 and V2, the tension in line 1 and line 2. I know that they should be subtracting from each other because they're acting in opposite directions, whereas these ones I'm adding because they're acting in the same direction. Okay, so with that, I've got a system of equations right now, and several unknowns. However, we know what A and B are, since we have those stored in the calculator right now. A is 67.4, B is 50.2 roughly. So if I know what A and B are, then really we only have two unknowns. So I've got a system of equations with two unknowns. We can solve that using any of your system of equations method that you already know from algebra, such as substitution, which I've got over here. So for substitution, I'm going to take this top equation for my horizontal parts and solve for V1. So if I do, I'm going to move this V2 cosine B over to the other side. So I'm going to add V2 cosine B to the other side, and then divide all of my parts by the cosine of A to get V1. And now that I know what V1 is, I can take V1 and substitute that back into our vertical equation here. So now instead of V1 sine A, I will have V2 cosine B cosine A sine A plus V2 sine B plus V2 sine B equals 5,000. Okay, so now I've got one equation and with only one variable that we don't know, V2. So I'm going to solve for V2 then. Since I've got a V2 in both of these, I can factor out my V2 from both parts to get this. V2 times every other term that I had here should be equal to 5,000, and then just divide by everything else. So if I divide both sides by cosine B sine A over cosine A plus sine B, I'll get V2 alone. Okay, so this is divide by everything that's not V2 on both sides. Okay, so if I wanted to type this in the calculator, it would look like this. I want 5,000 divided by... Okay, I'm going to put an open parenthesis here because I want to keep all of this part together. I'm going to put another open parenthesis because I want to keep the cosine B and sine A together. So this is the cosine of B times the sine of A. Okay, I'm going to close that top part of this fraction and then divide by the cosine of A. Okay, plus the sine of B. And close that last open parenthesis I had for the entire bottom part of this fraction. That's that parenthesis there. Okay, and that gives us 2169.514 newtons is V2. Okay, then I already have this equation up here, which we solved for V1. So I'm just going to take this V2 that we solved here and plug that back into our equation up here for V2. So that will give us V1 is V2, which we know is 2169.514 times the cosine B divided by the cosine of A. So I'm going to do that in the calculator really quick too. I'm going to take the answer we just got and multiply times the cosine of B. Answer times cosine of B. And then divide by the cosine of A. To get 3611.11 newtons. So those are V1 and V2, or the total tension in line 1, so this V1 going here, and our total tension in line 2, V2 going this way. Okay. I believe both of you don't have a microphone, so you can type in the chat if you want, but any questions on this one? Okay, I'm going to give you a second to type. Okay, got no questions from Kyle. Going once, going twice. Sold. Okay, so I'm going to say no questions from Kenichi. Kenichi, you can keep typing. If you've got one, I'll stop. All right, last one. Okay, a little bit more complicated conceptually. I've got masses connected by a rope over a pulley here, so mass 1 and mass 2, and a handful of questions I want to solve. So acceleration on mass 1, mass 2, and then tension on mass 1 and mass 2. For all of the questions that we do with pulleys in this class, I'm going to assume that the pulley has no mass. If that means nothing to you, you haven't taken a physics course, that's okay. But what that means for us is the same forces. The same net force that's acting on this system is going to cause it to move. So that means the total acceleration of this system, because our masses are connected, is going to be the same. Okay, so I'm going to start by drawing all the forces that are acting on our system. So here's what that would look like here. I've got force 1 here in red, is my force of gravity acting on mass 1. Okay, then I've got a force of tension. So that's the force that's actually causing it to pull upward. And then for our mass 2, I've got the same thing. So there's some force of tension that would be causing it to force upward, and a force of gravity that is causing it to go down. Now to make this easier, I'm going to say everything going to the right will be positive, and everything going to the left will be negative, if you want to think of it that way. So what that means is, since my mass 2 is 13 kilograms, which is more than my mass 1 of 7 kilograms, as soon as I release these, what's going to happen is mass 2 will drop, and mass 2 will start to rise, right? Because mass 2 is heavier. However, my total force is going to depend on both of those. Zoom out for this. My total force is going to depend on both of those forces of gravity acting on those masses. So I've got this force of gravity, force 2, is larger than this force of gravity, force 1. So my total net force is going to be my force 2 minus force 1. Okay, my total net masses would be mass 1 plus mass 2. So then if I want to solve for my total net acceleration, that would be, if my force is mass times acceleration, then I can solve for acceleration. So my acceleration is force divided by mass, or this. Okay, and I can plug in everything I was given. So acceleration due to gravity again is 9.8 on Earth. So this is 13 is my kilograms for mass 2, times 9.8 is the force of gravity, minus 7, my mass 1, times 9.8 is my force of gravity, and then plugging in my mass 1 and mass 2 gives me a total net acceleration. So this is the total acceleration acting on both blocks at the same time, is 2.94 meters per second squared. Now I don't have a sign on that. For this acceleration, my block 1 would end up accelerating upwards, and my block 2 would end up accelerating downwards. To make things easier, I'm just going to call this positive. So you can think of this system as going left or right instead, and we are going right. Okay, so then if I want to solve for the tension, I can look at each block individually. So my total force that is acting on block 1 should also be equal to the mass of block 1 times the net acceleration on block 1. So that would look like this. If I only look at block 1, so here's mass 1. That mass 1 has a total net force of its force of gravity, force 1, minus its force of tension, which is equal to the mass 1 times its net acceleration, which we just found was 2.94. Okay, that acceleration is going to be acting in the direction that is opposite to this gravitational force. So if I say the weight of this mass is 68.6, then its tension is opposing the weight and its acceleration is opposing the weight. So that'll make my signs look like this. So I've got our weight, which would be 9.8 times 7, or 68.6. Minus our force of tension, which is what we want to solve for, should equal my 7 kilograms times my acceleration, 2.94. Okay, so I've got 7 times 2.94 is 20.58. I'm going to subtract my 68.6, and that gives me 89.18 newtons for my force of tension in the line. Okay, if I had looked at block 2 instead, we would end up getting the same answer. So here's the same thing for block 2. Has some force of gravity pulling down and some force of tension pulling up. So I'm going to subscript this F2 to match my picture up there, and T2. Okay, so if I do that, then our equation would look like this. My total force should still equal my mass times my total acceleration. My total forces acting just on mass 2 are the force of gravity and my force of tension, which should be equal to my mass times acceleration. So our acceleration again is 2.94. This time it's acting in the same direction as gravity, so I'm going to keep this positive. So my weight was 127.4. My tension would be acting in opposition to gravity, so that should have the opposite sign. So my mass then is 13 times the 2.94 should give me my total force is 38.22. So my total force right now is 38.22. I can subtract my gravitational force right now to solve for my force of tension. So that gives me 89.18 newtons, which is the same answer that we got by looking at the other block. The tension is the same because this is the same line right now, and our pulley is massless. All right. So that's it for the first day. If you can think of your question, let me know in the chat, and I'll help you out. Thank you guys for coming, and I'll see you guys on Tuesday.